Hello everyone. Here we have an 80-pound ball is suspended from the horizontal ring using three springs, each having an unstretched length of 1.5 feet and stiffness of 50 pounds per feet. Okay. Determine the vertical distance h from the ring to the point uh, A for equilibrium. Okay, so this is the problem which is at hand. For this problem, if you look at the figure, you can easily say that in this problem we have a ring in which from the ring there are three springs which are 120 degrees apart. Okay, and each spring have an unstretched length of 1.5 feet, and each spring also have the same material stiffness, which is if you look at it 50 pounds per feet. We need to determine this vertical distance h from the ring to the point A to find the equilibrium of this force system. Okay, so for this calculation of h, we will draw the FBD first. If you look at it, we have drawn this FBD. We have taken, as we have said, the point A is for equilibrium. So we consider this point A as the equilibrium point, and we draw our axes, as no axes are defined here, x, y, and z. You can see in the FBD, x plus xi plus x plus y plus z, and the three springs directions are shown. This spring is this one, the other two are shown in the yellow. Okay, these three springs are shown as in this FBD, and here we assume that this spring is making an angle gamma with the z-axis, same as this spring making an angle gamma, and same as this spring making an angle gamma with the z-axis. Okay, so we now basically going to, and we also have in the FBD, you can see this ball of 80 pounds is being hanged from point A. So let's start the solution of this problem at hand. Okay, let's by seeing the FBD, we can say that we calculate the forces about the z-axis. Okay, so we say that summation of all the forces about the z-axis must be equal to 0. Okay, so if we say summation of all the forces about the z-axis must be equal to 0, this is our z-axis. Okay, this is our positive direction. You can see from the FBD as well. Okay, so when we say if you look at this figure over here, if you look at this figure, okay, that's from here to here. Okay, if you I draw this, this is the base, this is the perpendicular, this is the hypotenuse. So for z-axis, the base will be, we can take cos gamma. Okay, and the perpendicular is this, so we will take cos gamma. So we can say very easily that there is a three springs, so we can say FSP plus FSP plus FSP. Okay, and we can say cos of gamma, and there is a weight of the ball acting in the negative direction of the z-axis. So minus 80 is equal to 0. Okay, we can further simplify this equation if we want to. FSP plus FSP plus FSP will give us 3 times of FSP cos of gamma minus 80 is equal to 0. Okay, so let's cause this equation as our equation number 1. Okay, 3 FSP cos gamma minus 80. Now we will be interested in this parameter FSP. Okay, you know what is really this FSP is. Okay, we can say we know that FSP is equals to K times of delta X. okay, for the spring force. FSP is the spring force, okay. So we can also say that FSP is equals to K times of delta X can be given as like this: final length of the spring minus the initial length of the spring. Okay, we can say it is the final length minus the initial length of the spring. Initial length of the spring is given. Okay, now in order to calculate, we know that we can further simplify this as FSP is equals to K times of final length minus 1.5. Okay, but in order to calculate the final length, we have to draw uh, a small figure out of the main diagram. Okay, if you look at this figure, this, okay, we can just draw it like this here. Okay, if you agree with me, uh, this is our edge. This is going to be 1.5 feet, and this is our final length. Okay, this is, if you look at it, uh, this final length is basically uh, this is the final length. This is the, from starting from here, this is the this is the final length. This is 1.5 feet, and from here to here, this is, from here to here, this is h. So now we can say that the angle given here to us is, this is, they have given us is, this is gamma. Okay, in order to calculate the final length, we can make use of our function of trigonometric function, is that we know sine gamma is equal to 1.5 over the final length, which is the hypotenuse. So we can calculate the final length equals to 1.5 over sine gamma. Okay, so final length has been calculated. So we can say that if this is equation 1, you can call this as equation 2. Okay, so put put LF, final length, in 2, which is equation 2. So we get this equation as we can say it as FSP is equal to material constant, material stiffness is 50. What is the final length? We calculated it as 1.5 over sine gamma, and what is the initial length? Minus 1.5. All right, this is being done. So we have calculated the value of FSP. So we can put this value, and we can say this value equation as, we can say this is equation 3. Okay, so we can say that now put equation 3, put FSP we just calculated in equation 1. So we get the value as 3 we get the value as 3 times of FSP. Okay, so this FSP over here, we can put this equation. If we simplify this equation, or rather we can do one thing here, is that we can simplify this equation to further, for our easiness, we can simplify. If we simplify, so we can say FSP is equal to, if we multiply 50 with this, 1.5 times sine gamma, and again we multiply 50 with 1.5, so we will get FSP equals to 75 over sine gamma. Then multiply with this, we get minus 75. Okay, so this is the simplified form, and make this as equation 4. Okay, so we can say very easily say that put FSP in equation 1. So if we put this FSP in equation 1, we will get it as over here. We will so we will get 3 times of the put FSP value is what? It is 75 over sine gamma minus 75 cos of gamma, and we can further say that minus 80 is equal to 0. Okay, so this is trying to form into a trigonometric equation, and so after performing, we can basically 375 sine gamma minus 75 times of cos gamma minus the 80 equal to 0. We can simplify this trigonometric equation. Simplify trig equation. We simplify this trig equation, we will be getting it as tan of gamma is equal to 45 over 16 into 1 minus sine of gamma. Okay, once this is done, now what you can say is that this is a more simplified and equation now in terms of tan and sine. So you can use longer techniques you have done in your A levels and your college studies, that how to solve this trigonometric equation. But in order to, there are different methods. Either you can use method of hit and try. Okay, hit and trial method to solve this equation, to solve, or use scientific calculator, ठीक है, we will use the scientific calculator to solve this above equation. Okay, we will use and our target will be to get the value of gamma. Okay, so if you wanted to see how this trigonometric equation is solved through a calculator, you can go to my videos that will be on the right at the top right, and see how I've solved this equation on the scientific calculator and watch my video. Okay, now we will, after solving, we can say that we get gamma is equal to 42.445 degrees. Okay, once we have calculated this gamma of ours, okay, now as once we have calculated this gamma, we will be interested to calculate h. Okay, this gamma is found, we can calculate h if you from this triangle. Okay, so what will be if we say tan of gamma? Tan of this gamma will be 1.5 upon h. Okay, so we can say from the figure, from from we can use the from triangle, from the triangle we can say tan of gamma equals to 1.5 upon h. Okay, and from here we can say h is equals to 1.5 over 10 over 10, and gamma is what? 42.445 degrees. Okay, so very easily we can calculate our required h that was being asked is equal to 1.64 feet. Okay, so it was a good problem in which we understood many techniques of in which we also say how to solve a trigonometric equation by hit and trial method. It's a lengthy method. You can see it in the appendix of your R.C. Hibbeler book. But the most easiest is we will use the scientific calculator to solve a trigonometric equation. And you please watch my video coming on the top right to how to solve a trigonometric equation that will help you solve any trigonometric equation which will come in your studies of engineering mechanics, statics, or dynamics. So I hope you understood this this problem, this challenging problem, and you have a good day. And I see you in the next problem. Thanks a lot.